Now let's go ahead with a demo of the word count example. If the VM is ready, we can go ahead and have a look at the code directly. That's what we are going to do right now. So let me log in. So Eclipse is coming up. We are going to walk through the complete code. Let me close this. That's okay, I don't need that particular file. I just want the simple word count example. So what am I going to do is, I'm having it in the recording so that people will know how to go about it. This is going to be a pseudo-distributed system. So if you're doing it for the first time, let it be there in the recording. I will create with a new Java project. Of course, you have the recording, but still, let me go ahead and do that properly. Let's call it as first MR, first MapReduce, and let me click on finish. So I'm going to say first MapReduce. Now once I create a project, I will have the source, and I need to go ahead and create a new package. Oops. Let me close this. By mistake, I had clicked on a new window. So right click on this and I will say new package. The package I'm going to say is in.edureka, and I would say finish. So the package is ready. Then I'm going to say right click, new class. Let's call it as word count testing, word count testing. And I am going to go ahead and say public static void main, and I would say finish. So I'm creating a new class right from scratch. I would need some library files over here, so I need the jar files. So let me go down to my LMS. Let me minimize this. I'll go down to my LMS. Let me double click on the LMS. And in the LMS, if I go down to MapReduce, I have got a folder called as jars. Sorry, not this jar. I need all the jar file for running my programs. Okay, so where is all the files? The files are there. First of all, let me open up my word count testing. Okay, so that should be there in, let me check, I don't remember which one. Yeah, this is word count.java. So let me open up the word count.java file. Okay, and I will explain to you line by line as to what is happening, guys, so that you are very clear as to what we are doing. Let me just copy paste these things into my Eclipse. Okay, Control C. Let me go down to my Eclipse. Where is my Eclipse? Too many windows. So let me go down to my program and let me paste it. Control V. And the class, I'm going to keep it as word count testing because that is the name of the class that I'm having. So now you will see that it will give me a lot of errors. Why? Because I don't have the packages. Okay, let me click on save and I'll show you from where you can get your packages. So I will say right click. Come on, why am I clicking twice? So right click. I will go down to my build path. I'll go down to my configure build path and I will add my jar files. Where is my jar files? It is there in my user lib Hadoop. So I'm going to go down to my lib. Let me go down to my Hadoop folder. In Hadoop, if you go down to your share, Hadoop, if you go down to your MapReduce, and if you go down to your client tabs, just give me 1 sec, go down to your lib, okay, select all these jar files from the lib. I'm selecting all the jar files from the lib and I would say okay, let me see if this picks up everything. No, I need some more additional jar files. So that those jar files are there in my, let me do right click, build path. It'll be there at the root of this. Let me go up 1 level up. Come on. Hide this, yeah, this is irritating. Yep, there will be MapReduce client dot jar. There it is. Okay, you have got client core and client common. I would say okay. Let me say, okay, I need more jar files. I'm deliberately creating multiple jar files so that you'll understand how it is working, guys, okay? Now, let me do again jar files. Now, if you go down to your, let me select all of these jar files. So, some of these things went away. MapReduce went away, but Hadoop.io is still there, okay? So, that means it needs more jar files. Let me go down to the build path. Configure build path. That means I don't need MapReduce. MapReduce is done. So I go down to Hadoop. I'll go down to HDFS. And in HDFS, I will select the jar files at the root. And I'll say, okay. Okay. So I need the jar files in the lib also. So let me select this. So I think in in the new VM, you have all the jar files available for you separately. But then in case if you did not have it, this is the way how you will have to do it. So let me select these jar files in the HDFS. Okay, I still require, so see here, there are some of these jar files that are still missing. Let me go down to the build path. It's better if you create it, copy it into one location. That will make your life easy. So let me go down to HDFS common. Let me go down to common and add the common jar files so that whatever is there in the common, that will be picked up, and you would see that those jar files are getting saved. Okay, so I have selected these jar files. Let me scroll down and see. Okay, of course I need to change the name of the class here, word count testing.class. Hey, come on, I thought I typed word count. Why in the world am I not able to type over here? Just give me one sec. Word count. Okay, looks like my keyboard is acting. Hey, that's very funny. Okay, word count testing.class, because I changed the name, right? Earlier it was wordcount.java. I changed it to word count testing. So I'm starting from scratch so that you know how to go ahead and put in the files. I need files from the MapReduce, I need files from the common, and I need files from HDFS. Okay, guys? So I have got these files. So now my code looks to be correct. And first step, you can create these classes separately. You can create a map class, you can create a reduce class, and you can create a public static void main as a separate class. But since it is belonging to the same logical unit, we are creating it as inner classes. Okay? So that's the reason why we are having it in this fashion. Cool, fantastic, thank you. So now, guys, it's a little bit irritating because that window keeps on popping up about the this being there, what I call the number log being there, on and off and all that, okay, like what you see right now. So I'm just going to minimize this. So, or else let me do it here itself, leave it. So let me continue. I thought of doing it from my notepad, but that will be difficult. People might not understand it. Let me continue from here. This is the code what you have. Inside the map class, okay, now every map class should extend a class called as mapper. And any idea, guys, what are these 4 parameters what you're having inside the map class? These are called as generics. Key in, value in, key out, and value out. So I'm having the parameters for the current job. Okay? So that's what we are having. It is called as generic so that it will allow you to do compile time safety. So that's what we are doing here. Then you will override the map function. Guys, what are the 4 life cycles? Generics are there to avoid compile time safety. So if you have gone through the Java classes, they would have touched base on the generics. Generics is there for compile time safety. These are all Java terms. If I don't put in the angle brackets, you will, if the types are not proper, you will get an error, but you will get an error at runtime, not at compile time. So generics allows compile time safety. So now, guys, what all are the 4 life cycle, or what is the life cycle methods of the mapper? It is same as class templates in C#. That's correct. It is there so that it will be helpful in getting the compile time safety. Cannot change your generics because what is the key to the class? It is a offset point and a text, and the output is a text and a int writable. That's the reason why we are keeping it in this particular fashion. This is very particular for your individual mapper. Cool. No, map, combine, and reduce is not the life cycle of the mapper class. So how to see the life cycle of the mapper class is what I'm going to show you right now. So let me minimize. So let me go to the right. I wanted to minimize my Eureka VM. So if you go down to your file, same place where Hadoop is installed, USR, lib. Let me go down to USR lib. In a real world, please remember you will not be having the your Eclipse on the environment wherever you're going to deploy it. Your Eclipse will always be there in your development environment, and you will be working on a production environment. So if I go down to Hadoop 2.2.0, if you go down, you will not see over here. Let me go ahead. You don't see a folder called as docs over here. The documentation is not there because this is the minimum package that is there. Hey, Nagesh, offset point is the cursor position. It always starts from 0, right? Last time, if you look at my document, Nagesh, I had said 0, 16, and 30. How did I get 0, 16, and 30, friend? The starting point and the number of characters. Okay? Yes, there would be a dev, QA, and production in Hadoop also. So you don't see docs over here. So what you will have to do is you will have to go down and download Eclipse. Go down and download Hadoop. So if you go down to and search for Hadoop download, because you have to understand the documentation. Yes, you will quickly go through this, but then it is very important that you understand what the documentation is. So let me go down to Hadoop releases. And if I click on download, let me copy this and put it for you into the chat window so that you would know from where you can download this. Let me put this into my documentation too. Let me say new normal text. Let me click on save so that it will take me to, let me go to the right place because I was in a separate location. So I will go down to Edureka, Venkat Sessions, Feb 21st, and let me call this as day5.text. And I'm going to document it, Hadoop download link. So you might be wondering, why am I downloading Hadoop? You're downloading Hadoop because you need to look at the documentation. When you click on download a release now, it will take you to a page from where you can download it. Always go ahead and choose the mirror what is suggested by Hadoop, by Apache. So this is the mirror that is closest to you proximitically. Remember I told you about proximity? This is a lovely example of proximity. Now if I click on this, if I click on whatever version of Hadoop that you want, you don't have Hadoop 2.2, so go ahead with Hadoop 2.6, doesn't matter, and you will download your tar.gz. This is the link what you need to download, guys. So once you download this tar.gz, you can extract it and then go ahead. Okay? As if this is a place from where you'll have to download it so that you will get the documentation. Let me also do it because I don't have 2.6. So let me quickly go down to my D drive, customers. Let me go down to my Edureka 10-week session. And I'm going to go ahead and download this myself, 186 MB file. It'll happen very quickly. Okay. After that, I'm going to go ahead and show you the documentation part of it. Okay. So all of you, why am I doing this? Because I wanted to show you how the documentation is. So till the time Hadoop gets downloaded, I already have got Hadoop downloaded in a different location. So Let me go ahead to that particular location. Why am I doing this? Because I want to show you the API. So you have to download Eclipse so that you can look at the documentation. Understand it, why are we doing it, guys? Okay? So if I go down to the software, one is just look at the code and ensure that you do the code, but other is you will have to actually look at it. I have got Hadoop 2.2.0, the old tar file. So from wherever you are downloading Hadoop, once you extract it, you will see a folder called as, hey, I think it is there, just one second. They changed the documentation to share. Inside share, you have got doc. Just one second, guys, let me go down to the VM and see if it is there. Folder called as docs, okay? But then I realized that they have kept everything in share now. It might be there, I would be wrong. If it is there, you don't have to download it. Go to share, it is there. Inside share, if you go down, you would see something called as doc. Inside doc, you will see something called as Hadoop. And in Hadoop, you see something called as API. So you don't have to download it at all, guys. Okay? So it's good because I downloaded it because I wanted to have a copy of it. In the real world, you will have your Hadoop in a Windows environment, and the program would be running in a Linux environment. Your cluster will be in a Linux environment. So no need to download it, guys, because it is here. So if you look at API, and if you double click on index.html, now you are is an executable file. Let me say run. Let me see if index opens up with the browser here. I need to check if it does that. Let me do right click. Let me see if it comes up. I really don't know. Within the Edureka VM, how would it work? Just give me one sec. I will say open with another application. And I needed to look at the internet. Yeah, there it is. I can open it up with a web browser. And I will say open. It will open up the documentation for me in a web browser. That should be okay. And by the way, my Hadoop 2.6 is already finished downloading. Yep, 98% done. Let it open up. This is what you guys will do. You don't have to download it, guys. So don't worry. Don't waste your bandwidth. You can easily, it is there within the VM. So you can see it's opening up. And this is where you will see your documentation. Wait for a couple of seconds. And there it comes. So Java guys would know what this is the documentation. And if you look at the package called as org.apache.hadoop.MapReduce, org.apache.hadoop.MapReduce. If you look at the MapReduce package, and if you scroll down, there will be a class called as mapper. I am going to click on the mapper class and see over here how it is beautifully explained to you what is the key value pair. Got it, guys? If you are a non-Java guy, forget what is all of these things because you might never have to do this. But if you are a Java guy, it is important. So see over here how it tells you MapReduce input key value pairs to a set of intermediate key value pairs. So if you scroll down, I was talking to you about the lifecycle method of the mapper. The lifecycle of the method of the mapper is there is a method called as setup, which is called once. Then there is a method called as map, which is called for every key value pair. And then there is a method called as cleanup, which is called when the job finishes. This is what is the lifecycle of the job. I'm going to document this over here. So the life. Not of a job, sorry. The life cycle of a mapper is your setup, then your map, and cleanup. I'm just showing you a location from where you can understand all of these things. So I'm just letting you know how you can go ahead and have a look at the documentation. Each and every class what you're having is mentioned over here. So this will help you a lot to identify what it is. Okay? So now let me minimize this and let me go back to my Eclipse. Where is my Eclipse? There is my Eclipse. So now you override your map function. The parameters of the map would be the same key value what is going into the map, and the third parameter will be context. Context is something that you will be using for writing out the values. And then of course you will have throws, IO exception, interpret exception, because that is a part of the syntax. What do we do in the map function? Your business logic. Whatever is your business logic is what you'll do it in the map function. So first I'm converting the value to a string. I'm using string tokenizer so that I can split up those values. Then I loop through the string tokenizer. I print out what is the value, that is every word, and to every word I am printing out my 1. So remember, the output of a mapper would be a list of keys and values, and that is what you are doing over here, folks. Okay? So this is the logic of how to print out the value. So understand this with the diagram, it will make your life very easy. So that's what you do it in the mapper. So every mapper you will go ahead and get the word and put 1 to it. Then comes your shuffler. The default shuffling is based on the hash of your key. Okay? Cool. Is this a part of the life cycle? So we need to get to the shuffler, right? Hey, shuffler is a part of the framework. So there is something called as partitioner that you will be using. In case if you wanted to do a custom shuffling, you don't want to do based on the hash of the key, you will do something called as custom shuffling. For that you would need a partitioner. We will see that in advanced MapReduce. Okay? So right now just focus on the core part of it. So right now there is a mapper. Where is the output of the mapper written? Output of the mapper is written in the local directory. Then the shuffler will automatically come and it will ensure that all the values for the similar key is brought together across multiple nodes wherever the processing happens, and then it goes to the reducer. So let's look at the reduce logic in your Eclipse. Let me have a look at the questions. Int writable is a class. Okay, int writable and text are Java classes for the data types. So now what is the key in that is going into the reducer? The text and int writable, and the output is a text and int writable. Okay, so now I say text. Why am I saying iterable? Because it's a collection, it's a list, right? It's a list of values. So you'll get a key and a list of values, and all that I do in my reducer is my business logic. What is the business logic? The business logic is simply summing up the values. So this is what is the logic what we do in our reduce function. You do your aggregation, and whatever is the sum of the value, you will put it along with the key. So what is this? Key and the sum of the values. So if you look at the diagram, what would this be? Beer 2, car 3, deer 2, and river 2. That is what you are seeing over here. And then comes your driver code. What do we do in the driver code? See here, there are some comments. What is there, right? So this is what is the old API. Whatever is not with the comments, that is what is the new API. And once you do that, once you specify your input and output format, you are creating a path. Path is nothing but a class which will point to a file in HDFS. And then you specify your input and your output format. And what am I doing over here is, if the file is already existing, if the folder is already existing, I am deleting that particular folder. Because if I run this every now and then, it'll give me, I have to give a separate output file name, right? So that's the reason why I would go ahead and delete that output folder if it is there. And then this is the way how I will submit my job to the cluster. So it'll keep on, it'll submit the job to the cluster, keep on waiting till the time that particular job is finished. If you want to store images or graphic, you will have to create your own custom input format, and that's what we're going to see in advanced MapReduce. So this is the way how you will write your code. Once you write your code, what am I supposed to do? I have to create a jar file. I will right click on this. I will say export. I'll go down to the jar file. I'll say next. I want to see where the jar file is going to get saved. So it is going to get saved. Let me put it into the desktop. And the name of that is going to be word count.jar. And I will say OK. So I'm creating in the desktop a file called as word count.jar, and I'm finishing it. Okay. It has got some warnings. That's okay. And I'll close this. Because the warnings are there because I didn't write the word deprecated over here. I mean at suppression. So now I have got my jar ready. So what am I going to do now is, let me create a sample file now. So this is what the word count.jar that got created right now. On the desktop, I'm going to create a new file. Here, can't I create a new? Yeah, create a document, an empty file, and the file that am I going to create, just give me one sec, I don't know why this preferences is coming. Okay, it has gone. So the new file, I'm going to call it as words. Okay, I'm going to say right inside this, how are you doing with Java, friends? Hope it is not very tough. This is one of the ways of analysis. Non-Java friends can always use Pig and HIVE. I am creating a words file and I am saving this. I am going to do a word count on this particular file. I'm going to show you the whole life cycle, guys. So now I have got this. I need to move this to HDFS, right? So let me go ahead and open up my terminal window. There we go. I'm opening up my terminal window, and if I do a ls, I see that my file, what is the name of my file? I said words. Where is my words? Just give me one sec, guys. The file is called, just one second, guys, too many things. Words, yeah, I should see words over here. Am I missing it? Hey, just one second. Hey, let me do PWD. Hey, this is in home Edureka, whereas this is in the desktop. That's the pain point. Just give me one sec, guys. So I need to go down to the desktop. Okay, I'll do a ls, and I see my words file over there and my word count jar over there. Okay, thank you. So now I need to move this file to HDFS. So what do? I'll say HDFS put. So earlier in Gen 1 it was Hadoop. So I'll just press HDFS and press enter, and no, it is Hadoop only. It's not HDFS. So is FS over here, there is a DFS over here, and there is a FS also. So I could use HDFS FS, or I can use Hadoop FS also, either one of these things. So I'll say Hadoop FS space minus put space. What is the name of the file I want? Words. And where am I going to put? I'm going to put it into the root. So I'll say Hadoop FS space minus put. So it will copy the file from my, okay. Wow. My name node is in a safe mode. So let me do sudo, just give me one sec, guys, sudo jps. I need to come, password is Edureka. Okay. So no wonder my data node is gone. So I need to go ahead and do a quick restart of my services. So just give me one sec, guys. Let me go down to my README, because this is very specific to Edureka. In the real world, we will do start. Yep, reboot is required, but then there is a easier way of doing that also. Let me just see if they have kept it over here. Yeah, reboot will do that, or else I thought that they have kept, and there is one more way of doing it. Individually I could have kept, or else I'll just do reboot. That is the best way of doing it. So I don't want to show you other things. Okay, it is rebooting. Let it reboot, guys. So I'm going to go ahead and continue with a little bit of theory by the time this guy gets rebooted. So don't worry. So what did we do? We created the words file. We have created our jar file, and we will run it. The reason I had to reboot is because the daemons were not up. Hey, let's finish off with the hands-on. My system would have been ready by now. So let me go down to Edureka and let me log in. Okay, I'm just logging in right now. Cool. So now let me go down to the terminal window and let me say sudo jps, and let me ensure that all my services are ready. Okay, fantastic. So cd desktop, and I will say Hadoop fs space minus put space words, and I'm going to put it into my root. So the words file, I think words file is there. I don't remember, to be very frank. No, it is not there. Very good. So now I will say HDFS space DFS space minus LS space slash. So I'm seeing if the file is there. I just want to confirm, okay, that the file is there. And yes, the file is there. Looking at today's timestamp. Very good, guys. Okay, cool. Asif, DFS is there with your one command prompt, and Hadoop is there with other command prompt. That is what it is. Okay? Cool. So remember, if you look at your earlier session, DFS is used typically for your distributed. Both of them are same. Only thing is that they have got two separate commands. HDFS requires one thing and your Hadoop requires another thing. Hadoop requires DFS, HDFS requires DFS. Hadoop requires FS, HDFS requires DFS. That's all. Consider it as the same. Now I want to run my jar file. Okay, I'm going to say Hadoop jar. Let me type Hadoop and press enter. It has got this jar. See here, FS. Okay. So let me look at the questions. If there is any other question, fantastic. So now let me run this. Hadoop jar, my word count dot jar, my in dot edureka dot word count testing space slash words slash wc count feb. Okay. Sorry, this is March. Okay. Let me press enter. This will submit the jar file to the cluster. Okay, you will see it now. See how it is connecting to the resource manager at so and so. Okay, see the number of splits is 1 because there's only one map. Okay, then it will take up the job ID. See how it is running the job. Okay, and it will run the MapReduce and show me the output. This is aspect the Pacific time zone by default. Cool. Hey, sorry. 15, this is 15.3, right? 7. Yeah, this is as per the Australian time zone. That's correct. Yeah. I don't know which time zone. Yep. Number of reducers are not configured. It is based. Always there will be one reducer. Yes, the job will automatically be running. Okay. So look over here, the counters. What is the file system counters of HDFS? What is the MapReduce counters? How many lines did I have? See, map input records, I had 4 lines. There were 30 words that came in. Okay, there was no combiner. There were 27 unique words that was written. This is what is the MapReduce output that was there. Yes, counters are nothing but statistical information. Okay. com.in.edureka.wordCount is the package name. How do I run a jar file? Let me document that in case if it was not clear. We will say Hadoop jar, the name of the jar dot jar, then package name dot class name space the parameters for the job, parameters of the job. Okay, this is the way how you will run your typical jar file. So now let me go back to the browser and I'll go down to the name node status and I'll see it. Let me go down to the browser. I'll open up my name node status. I should see my, hey, it is running in offline mode. Why is it running in offline mode? Let me go down to Alt F. That's funny. Okay, let me press enter. This is crap. Let me scroll up. Alt F, sorry. Alt F. Let me uncheck that. It is unchecked. Okay, and it's connecting. Now let me go down to the browse the file system. I should see the output as word count March. And once I see the word count match, I'll see the reducer file, and there it is. I tried to keep it unique, but friends, is, and off came in twice. Okay? I tried to keep it unique, so you can see how you will be able to work. Cool. Okay? The number of splits is nothing but the number of blocks. Okay, Asif? Cool. So this is the way how you will run the complete MapReduce. I've given you a demo so that it will become clear to you guys. Let's go ahead with a little bit of theory now, friends. So we are in our module 4 now. And we are going to continue with our MapReduce. Today we will finish this, and tomorrow we are not going to start with advanced MapReduce. We will start with PIG. I'll give you one more week for people to understand this, because advanced MapReduce is a tough thing. Okay, so it is necessary to understand that. So you get one more week for covering up the Java part of it. Next Saturday is when we will do advanced MapReduce. So in this example, in this chapter, we are going to cover input splits. So remember, somebody asked me what will happen if a input split gets spread across 2 nodes, 2 blocks. We are going to see that. We will look at the complete MapReduce job submission flow. And somebody spoke about partitioner and combiner. We will talk about that. Look at the codes in detail. Of course, that's what I'm doing right now. And the code in MapReduce for a given problem statement. So that you will understand, once you know the basic, what is a mapper, what is a reducer, what's a driver, it will become easy for you. So this is what we had seen till now. What is the traditional way versus the MapReduce way of analysis? We know what is your Gen 2 MapReduce architecture. That's what we spent time last week on. And we understood what is the MapReduce application flow. Okay. Now this is something that is very important for you to understand. When I store my data, that is the time when it will get copied into the different blocks, which is physical, whereas input splits is logical. Okay, so input split is nothing but, typically the input split is what is going to be a block. So it will, that means for one block there will be one mapper. It will keep on looping through all the records inside that mapper, and that is what the framework does. Okay, so this is what is input split. So now let's understand this further. So let's understand the relationship between an input split and HDFS block. Please remember, at the time when I'm storing a file, since I'm cutting it into blocks of 64 MB, okay, so you can see what is the block boundary over here. See over here, so at 64 MB I will cut through a block, but at that time not necessarily my record will be cut, right? So wherever 64 MB come, it will cut it. So it might happen that record number 5, part of it is there in block number 1 and part of it is there in block number 2. Okay, similarly for 9 also, part of it is in block number 2, part of it is in block number 3. So logical records do not fit neatly into your HDFS block. Logical records are lines that crosses the boundary of the blocks. So the first split contains line 5, although it spans blocks. So the block from wherever it got started, that will contain the split. So internally what it will do is, so whatever is there in your second block, the physical block, the framework will ensure that the second block will give that part of that record to the first block so that the processing can be done by block number 1. Am I supposed to do anything specific for this? Absolutely not. It is the framework which will take care of doing this, guys. Okay? So this is what is your difference between the input split and block split. Hey, Asu was asking, what are the splits logical file names? Splits are nothing but records, Asif. So let's say you have got a record. Okay, the record, if you break it up into 2 separate things, so more than 128 megs, see the block boundary will be at 128 megs, right? So exactly at that time it will cut it. So maybe a part of your record is there in the first one and the part of this record is in the second one. Input split, okay, let me go back to the earlier diagram. What is an input split? Input split is nothing but a set of records that needs to be processed by a mapper, right? Let me document it so that it will become very clear. Input split is typically a block which contains records to be processed by a mapper. Okay, there will be, let me put a word, let me wrap it up. There will be one map which will process one input split. Okay, in some cases a record from the first input split will be spread across two blocks. What are these blocks? Physical, okay. These are physical blocks, and in such cases the framework will ensure that the part of the record which is in the other block is given to the first block so that processing can happen. I hope that makes it very clear, friends. There should be no confusion right now, friends. Hey, sorry, this should be 128 megs. Did I say 64 somewhere? Okay, it is 128 megs. If one record has more than 128 MB, how will Hadoop handle it? Hadoop will still handle it. It's a very good point. So take an example. Okay, I have got an audio file of 640 MB. Okay, so if it is 640 MB, it will be there in 5 blocks, right? But can I analyze it parallelly, all of those things? No, because for doing any process it has to be together, so it will be brought together in one particular block, one particular node, and then the processing will happen. So in such cases parallel processing will not happen if the file size itself is big enough. So let's move on. So see how if you look at the MapReduce submission flow, the input data is distributed to the different nodes. Is this block split or input split? When I said the input data is distributed to the nodes, we are talking about the block split. We are not talking about the input split here, friend. Input split is done only when I'm analyzing something, not at the time when I'm storing it. When does input split happens? Input split happens at the time of processing. When does block split happens? At the time when I am storing a file. Okay, when write happens, it will be there, or else read would happen. So here I'm talking about the write. Then each map task works on the split of data. Okay, so here we are talking about the input split. Then the mapper outputs the intermediate directory to the intermediate folder. Data exchange between the nodes happens in a shuffle phase. The framework guarantees that all the values of the similar key will go down to the same reducer. The reduced output is stored back into HDFS. I hope it is very clear. There we go. So Annie is around the corner. So MapReduce programming model provides a way for reducers to communicate with each other, yes or no, friends. What is a way that it will provide reducers to communicate with each other, my dear friends? What is the way? And how in the world will it get communicated? Because all of them are independent of each other. How will it communicate? Heartbeat? Heartbeat is for the slave and the master to work. Right? So the right answer is no, my dear friends. So see over here, the answer is no. Reducers run independently and in isolation. Individual tasks do not know the input source. Reducer tasks rely on the Hadoop framework to deliver the right input for processing. So splitting of a file happens how? Remember I told you something earlier? Okay, I showed you a text input format also. So 1, 2, 3 or 4. So yes, it is not randomly. 1 and 2 is definitely out of the window. You don't have to specify it explicitly because the framework will do it for you. It will use a text input format. So splits is what we have already seen. This is what is a hands-on when people show, but I have done it. Now, if you look at the two components that we have in our MapReduce, in addition to what we have seen, there is something called as a combiner. So what are combiners? Combiners are an example of mini reducers what you have in the map phase. So think of this example. You have got a lot of similar keys in your map. So if you don't say anything, what would happen? Each one of them would be stored separately, right? So combiner helps us to aggregate the similar keys in our map example. So combiners are like mini reducers. Then remember I told you there is always a default partitioner that will be there. Partitioners are there by default. The default partitioner brings together, the shuffler will use a default partitioner to bring together all the values of the similar key. How did it identify the key? The hash of the key is what is considered for doing that. So if you wanted to write your own custom logic, you can do that also over here. Okay, cool. So now why is combiner called as a mini reducer is partitioner and combiner is a part of the framework, but it is done separately. One, combiner is done in the mapper part of it, and partitioners are used by the shuffler to partition it. You will see it, guys. Just wait for a couple of seconds more. You will see the explanation and an example coming down, and also as if you'll come to know why it is called as a mini reducer. So let me go down to the next slide. See over here. What does a combiner do? Combiner is like a mini reducer. That means it will do whatever the reducer is doing across all the nodes. It will do it on the same node. It passes the workload further to the reducer. It performs a local reduce. That's why it's called as a mini reducer before we distribute the mapper results. So the advantage of that is your disk I/O and your network I/O would be reduced. They are not related to each other. They are different as if. They are not at all related to each other. So now look at this example. This example will make it very clear to you. This is only a combiner. We are not talking about a partitioner. So imagine if there are two blocks, and if this is the value what you have on your left hand side in block 1 and block 2. Remember I told you there will be a mapper that will be running on each of the blocks. You can see here there are similar keys. B is similar, and in the second example, D is similar in the first block. In the second example, D and A are similar, right? So imagine if you have got a lot of similar keys, what does a combiner do? The reason it is called as a mini reducer or a local reducer is because it will aggregate the keys for that particular node only. So imagine if the values are written as it is, like what you are doing right now, will it not increase your disk I/O? Because where is the output of the mapper stored? On the disk. Okay, and will it not increase your network I/O? Because each of this value will have to be passed. But what does a combiner do? It is a local reducer or a mini reducer. What it does is it will aggregate the similar keys on a particular node. It is not going to replace your reducer. The reducer will aggregate the keys across multiple nodes, but it will add the keys on the local node. And that's why it's called as a mini reducer. And now you see B is coming 2 times, D is coming 2 times instead of sending it twice. Here also D is coming 2 times, A is coming 2 times. And then what will the shuffler do? It will get together all the values of the similar keys, and the final reducer will do a master aggregation across all of them. I hope this should be very clear to all of you. 1 and 3 shufflers are controlled by whom? By the resource manager. Okay, the resource manager is the one who is actually controlling what key should go down to from which node and all of those things, right? The actual shuffling is done on 1 and 3, but it is controlled by the resource manager. So you're seeing what is a combiner. It is very clear. Now shuffling here is done based on the hash of the key. Can shuffling happen on something else also? Yes. Let's say in the same example, I want to write a custom logic wherein I want from keys from A to C to be together, okay, and from D to Z to be separate. So here shuffling is based on the hash, but supposing I write a partitioner, okay, partitioner will tell the shuffler what to use. By default it uses the hash partitioner. So if you tell the shuffler that I wanted from A to C alphabets to be together and from D to Z to be together, how many separate values will be coming? Right now you have got A, B, C, D, E, you have got 5 values. But in case if my logic of grouping is, it's a kind of grouping, partition is a kind of grouping. If you say from A to C to be in one and from D to Z to be in another, how many separate partitions will be there? There will be 2 separate partitions. Okay, good. So if that was the case, then it will be A to C will be 2, 2, 1, 1, 1. So all of these 3 things will be a part of one partition, and this will be a part of another partition. That is what is called as a partitioner. You'll see it now. I'm just trying to give an example with the same slide so that it will become very clear. Okay, I hope it is clear. Let's move on. So Annie is around the corner looking at whether you have understood the concepts or not. Now, combiner works where? Mapper, partitioner, reducer, all of the above. So the combiner is going to work at the mapper level because it takes the output data from the mapper and then go ahead and work on it. Cool. Combiner can be considered as what? Good. The answer is to the earlier question is semi-reducer. So the combiner works on the mapper output and it reduces the burden that you have on the reducer. There you go. So this is for people who wants to get the logic of the partitioner again. So what does the partitioner do? It decides how do I want to have the mapper output sent to the reducer. Sri, this is clear to you. This should make it clear to you. The partitioner decides how to redirect the output from the mapper to the reducer. By default, how does it redirect? It redirects it based on the unique keys that you have in the unique keys. That means hash of the key, right? Partitioner is basically to achieve multiple reducers. Hey, by default, there will always be one reducer. Don't take it that way. Partitioner is achieve multiple reducers. No. By default, there will be only always one reducer, Sneha. Okay. It will give it to the reducer, but all the similar values of, all the values of the same key is given to the same reducer, and the same reducer can run multiple keys also. Okay, Sneha? So if you look at this example, if you feel that there are going to be 3 reducers and you feel that there are 3 output files, no, that is not correct. Actually, only one reducer will do all these 3 things. By default, there will only be one reducer. Okay, get? Is there a one-to-one mapping between mappers, combiners, and partitioners? No, absolutely not. The combiner will do the semi-reducing at the mapper phase, and what will the partitioner do? Based on the hash. If you look at the deer, beer, river, car example, there are 3 inputs, but there are 4 unique values coming out, right? There are 4 distinct. So it is that way, Manish. So the purpose of the partitioner is to redirect the output from the mapper. Cool. So this is a very good interview question. That's the reason why we brought it. Can we use the same logic for the mapper and for the reducer? Yes. So you can do that, but then we are just qualifying it so that you understand it very clearly. You can do it as long as the logic is commutative and associative, and the most important is they have the same data types. If the combiner and the reducer are having different data types, then you cannot use the same. You might have to write a custom combiner. Okay, but in 95% of the cases, the logic will be the same. So the answer is yes, but for your understanding purpose, this is a part of a certification. So the reducer logic is commutative and associative, and the most important is that it should have the same data type. So yes, the answer is yes to the earlier question. So now interesting, guys. So this is something based on what you have already done. Nagesh was saying, how about having multiple reducers and bringing all the output from all the reducer input into one reducer? No, that will never happen, Nagesh. If you are having multiple reducers, you'll have multiple output files. That's the reason why you always have only one reducer. Okay? No, you can't do load balancing over there. Okay, forking data can be accomplished by having multiple reducers. That's correct. So you can have multiple output files. Okay? Cool, guys? Now, what is the answer to this one? What is the role of args? Public static void main args. So look at all the three options and then tell me what is it. Okay? So a lot of you people are directly jumping and saying 2. But look at the third one. Is third one not going deep down into it? So the right answer is 3. Okay? 2 is correct at a general way. The first is also correct. The first is also correct. Taking input and output from HDFS if the second was not there. Second is adding up more specific to what the first one said, and the third one is even more specific to what the first and the 2 said. Yes, so you're actually taking the path of the file. Where is the file? From HDFS, okay, from the command line argument. Okay, friends, so that's the answer. Can we change the output of the output key class and output value class? Very much. Most of you have got it correct. Yes, we said set output key value, set output file value. Good. So the answer is yes, like what I said. There we go. The next question what Annie has to ask is, what is text? Is it a data type? Is it a class? It's an interface. What do you feel, guys? It is a predefined class. Why should it be a data type? Is string a data type in Java? No, string is a class in Java, right? Yes, it's a predefined class. That's what Annie says. Now, there is a demo on the combiner and partitioner. The actual code, what we say is going to be there in your advanced MapReduce. So let me go ahead and show it to you. Let me go down. We will be doing this when we are doing advanced MapReduce. So let me go ahead and close my browser. Let me close my command line, and if I go ahead to my LMS, in my LMS, if you go down to MapReduce, if you go down to advanced MapReduce programs, see there is a folder called as combiner partitioner. We'll actually see an example of this in our advanced MapReduce. Okay, cool. Okay, so let's continue. So we will see this demo. So now we are going to have a healthcare data set. So this is how the healthcare data set would be, which is going to have some ID, some name, some date, some other transactional details, some email address, some other details, male, female, what is the type of disease and the age. Okay, so these are the, this is the data set what you have for healthcare, which we will be doing a MapReduce code on. Okay, we are going to de-identify the details. So this is the social security number is what Asif is saying. Good. So what do I want? I wanted to de-identify the code. So what are we doing here? You are going to use Scoop, which will push your data from the RDBMS onto HDFS. You're taking a data dump in the CSV format and put it into HDFS. You will read the comma separated value file from HDFS. You will write your logic to de-identify columns based on configuration, and you will store the de-identified comma separated value file back into HDFS so that it can be processed. Let me go ahead and show you the logic. Just give me one sec. I am going to go ahead with edureka.co. Just give me one sec. It is coming. Okay, there we go. Let me go down to my courses and my courses. And let me go down to the big data course. And let me go down to module number 5. Let me scroll down. I am in fact module number 4. If you look at module number 4, you will have calculate maximum temperature data set, find hot cold days, assignment, pre-work, those things are over here. And if you look at your advanced MapReduce, just give me one sec. So in advanced MapReduce, there is advanced MapReduce codes which you can download. Okay, so let me go down to module 4 once again. And yeah, as a part of the data set that you are downloading, okay, you will get this values also. Okay, so you will get this particular data set what we are talking about. This particular data set is also a part of the code. So let's move on. Now, if you look at the de-identify MapReduce code, let's look at the code to understand what it is. Okay, so see here, this is what the code is going to be. So in the mapper class, what are we going to do is, we are going to take an object as a key and text as a value. So these are all the attributes of the columns. The patient ID, the name, the date of birth, the phone number, email address, social security number, general, disease, and the weight. Okay? So this is what is all the examples. Hey, the context I told you earlier, context is for printing it out. Whatever you want to write out is what is called as a context over here. Okay, Mithun? Good. So Asif was asking, what exactly do we do as a Hadoop developer? Same scenarios as we do here or different? Most of the scenarios would be the same scenario. So here the generics are different, null writable. That's correct. So depending upon the output, so what am I saying over here? Null writable means nothing is going to come out of this. This is key in, value in, and I don't have a key. The complete text de-identified code is what is going to come out. So you, depending upon your key value, your generics will also change, Kirti. Got it? Cool. So first I'm taking up the string tokenizer. I'm separating it based on comma. I am putting everything. I'm creating a array. And then to that particular list, I am adding my encrypted columns. That is nothing but 2, 3, 4, 5, 6, and 8. So 1 and 7 is what I want. Then I write a logic. I'm just printing it out. I'm showing you what the string is. This is the whole code that will be there. We are just showing you what the value is going to be. Okay. So I'm just putting it into a loop over here. So you can see over here what is the token and what is the counter value. So I say, if the list contains some token, I'm writing the business logic. So what is this encrypt? The encrypt is nothing but a simple value which will take a key and then it will encrypt it. Okay? So what it is going to do is, why are we encrypting it? Because I don't want to show that other details. That's the reason why I'm encrypting it. Make sense, guys? The logic of the encryption is also shown to you over here. Else, I'll simply add it to the string and see how I'm writing the final output. This is what is the final output that will be there. The final output will simply tell me what is the text that I'm going to write. Okay? It will simply tell me the text that I'm going to write, friends. Fantastic. So this is the complete logic of the de-identification code. So depending upon your business scenario, you'll be writing multiple things. We're just showing you some example. And then in public static void main, see how am I writing null writable. Kirti had asked me what is null writable, right? See how am I writing null writable. And I'm specifying what is my output format. The output format is also a text output format. Okay? So this is the complete code. And this is the logic of the encrypt. This is a business logic. So this is what we have taken it up from the internet. It's easily available on the internet, how to encrypt a code. So after you run this, you will see that the final values gets encrypted, my dear friends. So what are we encrypting? We are encrypting all the other values which has got sensitive information. Cool. Hey, that's correct. The configuration value will pick up all of the XML files. It will read all the XML files, that is your core-site, HDFS-site, MapRed-site, and yarn-site. It will pick up all of the values. Let's move on. So see, we are going to show you the output of the example so that you'll understand it. So you can actually try that out. So whatever example is there, it is already there in your downloads. You need to actually try it out. Okay, cool. Hey, Krishna was saying, can you show us which line we are deciding which field to encrypt? Sure, Krishna, I'll show that to you. Let me go up. Let me go back to the earlier slide. So see over here, if the line contains some counter. So what is that counter is the logic that we are writing over here. I am putting everything. So I'm putting all the values. So based on the logic over here, if that list contains some counter, okay, then that is the counter that am I encrypting and am I adding it. If it doesn't contain that counter, then I am adding it simply based on a comma. Okay. So you need to look at the code to see what you want to encrypt. I wanted to encrypt everything else because it's personal information, and the only thing that I don't want to encrypt is the name and the disease. Got it, Krishna? Perfect. Good. So Asif, did you run this example? Were you able to get the final output value, Asif? Fantastic, Asif. So Asif, it was a part of which jar file? Fantastic, Asif. It is there in the LMS. Yeah, you can look at a MapReduce thing and it is there in the LMS. Fantastic, friend. Thank you. So others, please try that out. The next example what we are having is nothing but the weather dataset example, guys. Here, Yusuf was asking, does it contain the sources also? Yes. The text source for the value is also there. Yes, so the data is stored on the node based on the encrypted value. Yes, Sri, you have an original file like the words file that we had, Yusuf, and it is having the encrypted data also. So that is what is the hands-on that you guys will have to do after this session. You can download the complete data set from this location, weather data set. A part of the weather data set is already available as a source for you. Yes, Yusuf, the whole Java code is also there. It is there, Yusuf. Okay, cool. So now, again, why are we talking about this demo? This is a demo what you'll have to actually try it out, guys. You will have to try out the weather dataset example. And this is what I showed you, the MapReduce in the project. So where are we? I told you at the end we are going to show you an end-to-end project, right? So in the end-to-end project, this is the project that I'll be showing you on the last week. We are having huge raw XML files, and we will show you how to read from the XML file. We'll use MapReduce, put it into HDFS, then we will use Pick to process that file, use HIVE to do something else, using Scoop we'll be putting it into MySQL, and finally the output of that is what would be kept to you so that you can create a user interface and you can work on those things. So this is a complete end-to-end example, folks. Hey, that's right, Asif. So it looks like you've done all the MapReduce part of it. That's good, Asif. So this is what Asif is saying. No, Asif, this is a project what we will be showing it to you. You will have to do a project for your end-to-end certificate. Okay? So this is the huge raw XML files. So we will be talking about this when we go down to the last session, guys. What is category hash? The data is what will be shared with you, and we will be doing this complete MapReduce project so that you'll understand it. Cool, friends. Let me move on. So now, please try the maximum temperature problem in the MapReduce. Try to find out the hot cold day problem in the MapReduce. Do these assignments so that your concepts become clear. Please execute the codes that we have discussed it in the class, complete the assignments, and please read about, this is must, okay? So for non-Java guys, do what is there in your module number 5. It is very, very, very important so that you'll understand it. So I'm going to give you one more week because after this, we are directly going to go ahead with our PIG, which doesn't require any Java, and next Saturday after PIG we will continue on with our advanced MapReduce, because for advanced MapReduce you really will, that's why it's called as advanced MapReduce, right? So please read custom input format, sequence, and MapReduce. There are 7 separate sections of advanced MapReduce codes that we will try. Okay, so these are the things that we are going to do. What is map side join, reduce side join? What are counters? How can you start with a distributed cache? How to create a custom input format? One of you asked me about image files, right? Another of you asked me how to do processing on image files. This is the class, and then how to do unit testing. So these are the examples what we will be seeing it up on next Saturday. So this is your module 4, how to calculate max temperature, hot, cold days. Plus in the LMS, there are a lot of examples that you will have to work out with. And guys, please continue with the quiz. The quiz is very, very important so that you'll understand everything, folks. Okay?